Hello friends, today we will discuss the topic that is coagulation of colloids. We know colloids, the nature of colloids depends upon the nature of particles present in the colloidal solution. Some colloids are very stable and some colloids are very unstable. When the colloids will be unstable, then the particles will be settled down at the bottom of the container. This is called coagulation. That means it is the aggregation of particles of colloids, aggregation of particles of colloids into large size, forming precipitate. Aggregation of particles of colloids into large size, forming precipitate. That is called coagulation. When coagulation takes place, the DP will be separated from DM. That means from colloids there will be separation of DP and DM. That means the DP will be separated from DM, results coagulation, so that the particle size will be increased and formation of precipitate. That is called coagulation. Coagulation can be done different methods. What are the first method coagulation? First one is adding electrolytes. Electrolytes carry cations and anions. These electrolytes coagulate the particular charge of colloids. Already you know each colloids carry the charge, either positive charge or negative charge. As every electrolyte has cation and anions. And if the colloids carry either positive charge or negative charge, then what happens? These opposite charge ions will coagulate the charge of the colloids so that it will be precipitated. First one is adding electrolytes. Second one is by mutual coagulation. What do you mean by mutual coagulation? Mutual coagulation means positive neutralize with negative. That means positive salt mix with negative salt so that it will be neutral. Results neutral. Neutrals means neutralization of charge means resulting coagulation. That is called mutual coagulation. Then third one is by prolonged dialysis. That means continuous dialysis. If continuous dialysis will be done, it results coagulation. If continuous dialysis will be done, that will be results coagulation. Continuous dialysis results coagulation. Fourth one is excess cooling by or by heating. Excess cooling or by heating. That means if the colloidal solution will be heated strongly or cooled at very low temperature, it may cause coagulation. So excess cooling or heating, prolonged dialysis, mutual coagulation, adding electrolyte. Fifth one is very important, that already we have read, that is by electrophoresis. By electrophoresis. By electrophoresis, we can also coagulate the colloidal particles. If you continue the electrophoresis process, then the same charge particle will be attracted towards the opposite charge electrode, and at the opposite charge electrode it will be coagulated, it will be settled. That's why these are the 5 important methods for coagulation of colloids. First one is by adding electrolyte, by mutual coagulation. Third one is by prolonged dialysis. Fourth one is by excess cooling and heating. Fifth one is by electrophoresis. So first method that is adding electrolyte. Electrolyte carry positive charge and negative charge. It coagulates the particular charge of the colloids, so that colloid will be settled down, undergo precipitation. So which electrolytes are more effective, better coagulating agents? That let us discuss. The power of electrolyte, the coagulation power of electrolyte, coagulation power of electrolytes. Coagulation power of electrolytes is studied by Hadley and Skolch. Hadley and Skolch rule. What is this Hadley and Skolch rule? According to Hadley and Skolch rule, the coagulation power of electrolyte is directly proportional to the fourth power of valency of ion. What does mean? What indicates? Coagulation power of electrolytes. That means electrolytes means cation and anions. The particular cation or anion, its coagulation power over electrolytes depends upon the valency of the ions. +1, +2, +3 or +4 like this, the valency of ions. If valency ion is more, then coagulation power will be more. That is studied by Hadley and Skolch. For that, if compare the coagulation power over a positive colloids, so the power will be Cl- will be greater than sulfate ion, will be greater than phosphate ion. Sorry, it is the just opposite way. For here, coagulation power will be ferrocyanide ion. Ferrocyanide ion will be ferrocyanide ion greater than phosphate ion, greater than sulfate ion, greater than chloride ion, like this. Similarly, if you coagulate for negative salt, we can use positive particles, that is aluminum ion, more powerful than calcium ion, more powerful than sodium ion, like this. So if the colloid is positive charge, then this negative charge ion will coagulate, and the power of this negative ions, coagulation power, is in this order, that is decreasing order. 4 minus, greater than 3 minus, greater than 2 minus, greater than single minus. Similarly, for coagulation of negative salt, these cations will be more effective, because negative ion will be coagulated by positive ion. So 3 plus greater than 2 plus greater than n plus. This is the comparison of coagulation power of particular ions. And this coagulation power of electrolyte is measured by flocculation value. The unit is called flocculation value. Unit is called flocculation value. Flocculation value. Flocculation value means it is expressed by unit millimoles per liter. That means how much millimoles of electrolyte required to coagulate 1 liter of colloidal solution. For 1 liter of colloidal solution, how much millimoles of electrolyte is required for the coagulation? That is called flocculation value. So flocculation value is expressed as millimoles per liter. How much of, if flocculation value is more, flocculation value short form is FV, flocculation value. Flocculation value is inversely proportional to coagulation power. That means higher the flocculation value means more ions are required, more concentration required. More concentration is required means coagulation power is less. If you compare these ferrocyanide ions, it has more coagulation power than phosphate ion. If coagulation power is more, that means less amount of ferrocyanide ion will be required. That means if power is more, amount required is less. That's why high flocculation value means low coagulation power. If coagulation power is more, then flocculation value will be less, just opposite. If power is more, less amount is required. If power is less, more amount is required. That's why flocculation value and coagulation power of electrolyte is just inversely. So this is the regarding the coagulation of colloids, because colloids required what? Colloids carry charge. So charge of colloids, when it will be neutralized, then it undergo coagulation. Okay, so this is about the coagulation of colloids. Now we'll discuss the application of colloids. First application is as medicine. We know that almost all medicines are colloidal forms, because these colloidal forms of medicine, colloidal forms can be easily absorbed in our body. That's why it will be more effective. That's why all medicines are used in which form? In colloidal forms. All medicine are used in colloidal forms because it is more effective and can be easily absorbed in your body. So it cures disease very fastly. So this is called what? First, that is application is as medicines. Second application is that is sewage disposal. In sewage disposal. In sewage disposal means we know sewage water mainly contains colloidal particles. It carry different charge. Sewage drain water contains colloidal particles. It carry charge. When this colored sewage water, when passed through the oppositely charged plate, electrically high voltage oppositely charged electric plate, then what happens? These charged particle will be coagulated over the surface of plate so that the sewage, this particle will be settled down. That's why sewage disposal can be done. All this is the application of coagulation. The method is coagulation. This is also coagulation. Coagulation. So by coagulation techniques, sewage disposal can be done using opposite charge electric plate. Then third application is water purification. Water purification. Water purification means we know water contain different colloidal particles. When these water carry colloidal particles, when these colloidal particles will be applied different EDTA techniques, by adding EDTA, this water, calcium ion, magnesium ion can be absorbed by the EDTA so that it will be separated. Another water can be purified by adding electrolytes like sodium chloride and quicklime can be added. By using sodium chloride or that is calcium oxide, these things can be added to that dirty water so that it will be settled down by the coagulation of sodium chloride and calcium oxides. Alum can be also used. Alum is more effective than calcium oxide and also more effective than sodium chloride. So these things can coagulate the impure water so that water can be purified. This technique also coagulation. Fourth one application is cleaning action of soap. Cleaning action of soap. Cleaning action of soap. Soap itself is a colloidal forms. As due to formation of micelles by forming micelles, due to formation of micelles of soap particles, so it absorbs the dirty things so that from your utensil and from utensil or from your dirty clothes, the dirty things can be removed due to formation of micelles. Micelles is a associated colloid. So soap, that is cleaning action of soap is due to formation of micelles. Micelles is a associated colloid which helps to remove dirty particles from the clothes. So this is important application. Then that is formation of delta. Formation of delta. This is very important. Delta generally produced at the junction of sea and river, because river water carry colloidal particles and sea water carry electrolytes, that is opposite charge ions. When these two water will mix at the junction, delta, that is the precipitation takes place. This precipitation is obtained as delta. So delta is produced at the junction of sea and river due to coagulation of river water by sea water. Sea water carry electrolytes. So this is the application of coagulation also, by coagulation. Coagulation techniques. Number 6 application, that is smoke precipitator. Smoke precipitator. Here what happens, we know smoke carry colloidal particles. It carries charged particles. When this smoke will pass through oppositely charged plate, high voltage oppositely charged plate, what happens? The smoke particles will be settled down, gets coagulated. So that is also formation of, to control pollution. Smoke release from the chimney can be controlled by using smoke precipitator, which carry opposite charge ions of the smoke. That is also, that is coagulation. That is also coagulation techniques. Then very important application, that is also that artificial rain. Artificial rain. Artificial rain can be also done by this technique. All are mainly due to coagulation techniques. Artificial rain means the rain, that is cloud, carry charged particles, particular charge it carry. When the opposite charge artificial sand particle will be used, sand particle carry charge. That means activated sand particle will be used. This activated opposite charge sand particle will coagulate the clouds. So the clouds will be converted to rain. So artificial rain can be produced by the coagulation of clouds by charged sand particles, using sand particles. Using sand particle we can also coagulate. Then next one application, that is your rubber industry. In rubber industry, what happened? The latex produced from rubber tree, it behave as a colloids. When this latex will be coagulated using the opposite charge solution, then what happens? The latex will convert to rubber. From rubber tree, the latex will be collected, then the latex will be mixed with opposite charge solution, so resulting formation of rubber. So that is also very important, because rubber tree produce latex. The latex itself is a colloidal forms. The next application is that stop bleeding. That means by using ferrichloride. By ferrichloride solution, the bleeding can be stopped. When you apply ferrichloride solution at that wound place or cutting place, so that at the cutting place, this ferrichloride coagulate the blood particles, so that blood particles will be coagulated at the release point, so that it will be deposited at the veins, so that it will not be produced again. That's why ferrichloride stop the bleeding by coagulation methods. Then other application is very important application, that is that the purification of ores by froth flotation process. By froth flotation process. By froth flotation method. Froth flotation method is very important technique in metal extractions. That in froth flotation methods, what happens? Oils, water and air both will be mixed. Then when ore will be added, then ore and oil will be mixed and produced as a froth. And this froth itself is a colloidal form. This froth will produce and it will float at the over water. So it will be ore will be separated due to the formation of froth and it floats on the surface of water. That's why purification of ore can be done. The mineral that the impurity present in the ores can be separated by using froth flotation technique, because froth itself is a colloidal form. Then next application is that sky and sea is blue. Sky and sea is blue. Why? Sky and sea, or that this sky is blue and sea also looks like blue because due to what? Colloidal particles, that due to colloidal form, this scattering of light by the colloids, colloidal particle, scattering of light by colloids. Your sky contains clouds, dust particles. These dust particles undergo scattering of light, so it obtained as a blue color. So these are the one important application of colloids. Then another is smoke screen in warfare. Smoke screen in warfare. Smoke screen in warfare. In warfare, that can be as used as a smoke screen. The smoke screen means some smoky atmosphere will be formed due to formation of colloidal particles. So it can be used in warfare during war to that drive away the soldiers, opposite soldiers, using formation of smoke screen. Okay, so these are very important application of colloids. Most of cases, another very important application also you can add, that is use of silver bromide in photography. Use of silver bromide in photography. What is the role? Silver bromide solution will be used as a colloidal forms. When it will use over the photographic plate, due to the sensitivity of this silver bromide for light, it produce what? Photography. So that silver bromide for the light sensation, due to effect of light, due to its effect on the light, so it can be used as a colloidal forms. So these are some important application of colloids day-to-day life, because colloidal chemistry, the surface chemistry, is very important in our day-to-day life. It has application in all fields, so we have to read all application of colloids. Okay, thank you.